So the discrete random variable d has the following probability distribution, where k is a constant. Part A says we need to show that the value of k is 600 over 137, and this is for 2 marks. So we're going to have a look at the probability distribution here. Now the thing that we're going to use to work out the value of k is the fact that if we add up all these probabilities here, we're going to get 1. And the reason for that is because in this probability distribution, these are the only options we got. We got 10, 20, 30, 40, and 50. And altogether it's going to be 100%. Because as these are the only options, you're definitely going to get one of these. So if we add up all of their probabilities, we know it's going to equal 1. So what we're going to do is we're going to write that down here. So for part A, we got k over 10, plus k over 20, plus k over 30, plus k over 40, plus k over 50. And like we said a second ago, that's going to equal 1. And what's great is we've now got an equation, so we can just solve that for k. So I'm going to add up all of the left-hand side using the calculator. And doing that, we're going to get 137k over 600, and that equals 1. Now if we divide both sides by 137 over 600, we're going to get the k equals 600 divided by 137 as needed. For this question you get 1 mark for this line here, and then 1 mark for the final concluding line down here. So now part B says the random variables d1 and d2 are independent and each have the same distribution as d. And we need to find the probability that d1 plus d2 equals 80, giving our answer to 3 significant figures. And this question is for 3 marks. Okay, so we're going to refer back to the distribution at the top. And when you think about different ways we could have d1 plus d2 equaling 80. So the first thing that jumps out to me is we've got 40 here. So we could have 40 plus 40. And the only other option we've got is 50 and 30. So we're going to write down the options here. We could have 40 plus 40 equals 80. Or we could have 50 plus 30 equaling 80. Now we need to write down all the possible cases. So we're working with d1 and d2. So one of the cases we could have d1 equals 40. And then also d2 equals 40. And the next case we have, okay, so we're now going to refer to the 50 plus 30 equals 80 bit here. We have d1 equals 50 and d2 equals 30. However, we've got another case that we can extract from this. We say, okay, so this time we're going to say that d1 equals 30 and d2 equals 50. And those are all the possible cases we've got for saying that d1 plus d2 equals 80. So now what we're going to do is evaluate the probability that d1 plus d2 equals 80. I'm going to write here just a little note that for and, so when we say and, we're going to use multiplication, and for or, we're going to use addition. So our first case to get d1 plus d2 equals 80, we're going to have the probability of d1 being 40. And so if we look back up to our distribution at the top, we've got, okay, for 40, the probability is k over 40. And actually, we notice a pattern. For 10, it's k over 10, 20, it's k over 20. So we can work with that quite easily. So for 40, the probability is k over 40. So we're going to have k over 40. We need d1 to be 40 and d2. And because it's and, we're going to multiply. So multiply by k over 40 again. So that's one case. But now we're going to say or. So we can have this or. So I'm going to add. And we've got the second case. So d1 being 50 and d2 being 30. Okay, so if you remember from earlier, it's just so going to be k over 50. And we're going to have and. So multiply k over 30. And the final case, so or, it could be this case. We've got d1 being 30 and d2 being 50. So k over 30 multiplied by k over 50. So I'm going to simplify that a bit. So we're going to have k squared over 40 times 40. So 1,600. And adding to that, we're going to have k squared over 50 times 30. So 1,500. And lastly, we're going to add again. We're going to have k times k, so k squared over 50 times 30 again. So 1,500. And we can evaluate that on our calculator and we get 47 k squared all divided by 24,000. Now, but we know the value of k from part A. We know that is 600 over 137. It's going to equal 47 multiplied by 600 over 137 squared all divided by 24,000. and put that into the calculator. So I get 0.0375619 ... However, in the question it said 3 significant figures. So we're going to get 0.0376 to 3 significant figures. So we got our first mark here for working out all the cases that we could have. We get our second mark here for this line here, and our final mark for getting down to the correct answer to 3 significant figures. So lastly, look at part C. We see the value obtained D is the common difference of an arithmetic sequence. First 4 terms of this arithmetic sequence are the angles measured in degrees of the quadrilateral Q. And we need to find the exact probability that the smallest angle of Q is more than 50 degrees, and this is for 5 marks. Okay, so I'm going to define some stuff. So in our arithmetic sequence, I'm going to let A be the first term in the sequence. And we already know in the question it says that D is the common difference. And we're talking about the first 4 terms in the sequence. So the angles that they're talking about being the first 4 terms in the sequence, we're going to start with A being the first term. And because we know the common difference, we can just say, okay, that's A plus D. And now the next term is going to be A plus D plus D. So we can simplify that to A plus 2D. And lastly, following the same pattern, it's going to be A plus 3D. So we've got a key bit of information that we need to remember, that the interior angles in a quadrilateral add to 360 degrees. So we can use this to add these together and say, okay, so all these angles added together are going to equal 360 degrees. So we've got A plus A plus D plus A plus 2D plus A plus 3D. That's going to equal 360 degrees. Now we can simplify this a bit. So we've got 1, 2, 3, 4 A's. So 4A. And we've got 1D plus 2 plus 3. It's going to be 6D. That still equals 360 degrees. We can simplify this further if we divide both sides by 2. So, okay, so 2A plus 3D equals 180. Now, similar to the previous part in part B, we need to think about the different combinations we could have. And again, we're going to refer back up to the probability distribution up here, which gives all the possibilities of D. So D could be 10, 20, 30, 40, or 50. So that's what we're working with. In the question said we need to look for the probability when the smallest angle of Q is more than 50. Well, if we have a look here, we've got all our angles, A plus D, A plus 2D, A plus 3D. The smallest angle here is going to be A, because each one after that we're going to add something onto it. So our condition, we can simplify it to say, okay, so A has to be greater than 50. Then we're going to look at the possible cases. So A could be anything, but D could only be 10, 20, 30, 40, or 50, as in the distribution at the top. So if we had D to equal 10, we'd have 10 times 3, so 30. And then if we do 180 minus 30, so we've got 2A equals 150. And then we're going to divide by 2. We're going to have 75. So here we could have A is 75. So that works out with our condition, because A is greater than 50. And D is one of the possibilities from the probability distribution above. Now I'm going to try D equals 20. So if we sub 20 into here, we're going to have 3 times 20, which is 60. If we do 180 minus 60, we get 120. And dividing that by 2, we get 60. Or another possible case, we're going to have D equals 20. And when that happens, A is going to be 60. And again, that meets our condition of A being greater than 50. Now, the next thing we've got to try is D equals 30. So we're going to sub 30 in here. So we've got 3 times 30, being 90. 180 minus 90, being 90 again. And dividing that by 2, we get 45. And 45 is less than 50, so it doesn't match our condition. And I'm actually going to stop trying the cases here, because as the value of D gets bigger, we know that the value of A is just going to get smaller and smaller. So as when D equals 30 doesn't meet the condition, D equals 40 or D equals 50 won't either. So again, referring to the question, we need to find the exact probability that the smallest angle of Q is more than 50. And that is the probability of D equaling 10 or D equaling 20, as we worked out here. So referring back up to the distribution, it tells us that we're going to have probability of D equaling 10 is K over 10. And for 20, it's K over 20. And because it's or, we're going to add it. And that gives us 3K over 20. And since we've used this before, K equals 600 over 137, I'm going to sub that in the calculator. So we've got 3 multiplied by 600 over 137, all divided by 20. And that will give us 90 over 137. And this right here is our final probability. So looking through to see where we get the 5 marks. We get 1 mark here for identifying the angles. We get another mark for identifying that if we add them all up, we're going to get 360 because it's all the angles in a quadrilateral. We're going to get another mark for simplifying it down to this form. We get another mark for the cases here, and a final mark here for the correct probability.